All right, so one last thing with complex numbers here. We're going to talk about what we call complex conjugates, and then we're going to add in the division. So we did operations with addition, subtraction, multiplication. We're going to look at it with division here. So first off, a conjugate. So every complex number has a conjugate here. What a conjugate is, sorry, I got to focus here, my bad. What a conjugate is, so if I had like 3 plus 4i, its conjugate is going to be 3 minus 4i. Okay? If I had, let's say I had a complex number that was negative 7 plus 2i, its complex conjugate is going to be negative 7 minus 2i. Or I could have a complex number of 5 minus 3i. Its complex conjugate is going to be 5 plus 3i. Hopefully you guys are seeing some sort of trend here. All we're doing is its conjugate is just the imaginary part, signs changed. Everything else is exactly where it is. I could have just like 3i, its complex conjugate would be negative 3i, because it's 0 plus 3i, so it'd be 0 minus 3i, okay? So that's what a conjugate is. What we're going to use these when we divide here, guys. And whenever we do division, what we want is we always want our complex number to simplify down to the real number plus or minus the imaginary. That's what we want to get to every single time. And so just keep that in mind here as we go through this. So for example, let's say I had 5 all over, let's just start with a real number divided by a complex number. Let's say 2 minus 3i, okay? So I want to get this into the real plus or minus imaginary here. And how I'm going to do this with division is I'm going to times both the numerator and the denominator by the denominator's conjugate. So the denominator's conjugate is going to be 2 plus 3i. And I'm going to times both the numerator and the denominator by that complex conjugate. So I have to use multiplication with this. Look at what happens when I do that. So I'm going to distribute the 2 through, and my numerator is going to be 10, again, plus 15i. My denominator, though, when I go to distribute this through, let me just show you what happens with this. So I go 2 times 2, which is 4. 2 times 3i, which gives me 6i. Then negative 3 times 2, which gives me negative 6i. And then negative 3i times 3i, which gives me negative 9i squared. Okay? And then we're just going to simplify this a little bit more. So 10 plus 15i stays. What happens here? Those two cancel out, right? 6i minus 6i gives me 0i. And then here I get plus 9, because that I squared really is a plus 9. And I plus it to the 4, which actually gives me 13 here. Okay? So I have this divided by 13. Well, you might say, well, it's not in real and imaginary form. Well, it is. We just need to write it that way. This 13 is dividing both of those, so it's going to be 10 over 13 plus 15 over 13i. So your real number is your 10 over 13, and your imaginary is the 15 over 13i. So whenever you times by that denominator's conjugate, that's what happens. You end up with just a number. That's why we do it by the denominator, not the numerator. Okay, let's look at a couple more here. Let's go 4i all over. Let's go 2 minus i. So again, its conjugate is going to be 2 plus I, because I'm only concerned about the denominator's conjugate. I don't care about the numerator's conjugate, just the denominators. Then I times this all through. This is going to give me 8i plus 4i squared, and then my denominator is going to give me 4 plus 2i minus 2i, and then minus I squared. And I got to simplify this. This gives me just -4, so I've got -4 plus 8i in the numerator. And in my denominator, those two cancel out. This is just 1, which can combine there, which gives me 5. So that's what we get for that as well. Then I can just write this in its form, so -4 fifths plus 8 fifths I is what I get from that. And that would be my value that is simplified for me. Let's do another one here. Let's say let's go on with like 1 minus I here. And then we got, let's say 5 minus 3I here. Okay, so let's say we've got this in red here. I'm going to times, again, by the denominator's conjugate, which is going to be 5 plus 3i. And I have to do that both to the numerator and denominator here. So the numerator, there's just a lot of multiplication here. Is all we really get here. We're going to have 5 plus 3i minus 5i, and then minus 3i squared here. And then my denominator, when I multiply that through, I get 25 plus 15i minus 15i, and then minus 9i squared. And then we got to simplify this mess. My numerator, this is positive 3, which gives me 8. And then I can combine those two, which is going to give me -2i. My denominators, those two terms go away, and I get plus 9 here, and it can combine with that 24, which will give me 34. And then just write it in that form. So 8 over 34 minus 2 over 34 I. This is pretty close. I would actually simplify these fractions. It just, I don't know, makes things look a little bit better in that case, which we can take a 2 out of this, which would be 4 over 17 minus 1 over 17i. Bada bing, bada boom. Trying to get it to its simplest form the whole way. So again, keep those rules straight. We're just timesing by the conjugate's denominator, and that's the route we're going. Okay, that's it. Adios.